All right, so I'm going to take you over the multiple choice for AP Classroom from Recap 7. First, I'm going to go through that last problem from the recap video. I feel bad that I kind of quit on you. It was my birthday. I am younger than Mr. Lakin. It hurts me that some of you don't recognize the youthful energy, although some of you did, and that made me happy reading your responses. But yeah, he's 36 and I just turned 33. Come on, people. Come on. Okay, so this one, I mentioned at the very end how you would do it, and then I didn't actually do it. So you want to maximize the red rectangle, which would be something that we've done in the past. So the area would be 2x times y, but we know that y was equal to cosine of x. So really our area right here is what we're trying to maximize. So take the derivative, set that equal to 0. I used my calculator. Some of you asked why we're doing calculator questions when the free response questions won't be calculator. Just because they're not calculator active doesn't mean you couldn't use your calculator, okay? And there's still some good concepts we can practice even though our calculator might be doing some of the heavy lifting. So I found the area of that rectangle was 1.12219. Please note that I stored these as decimals in my calculator so I didn't have any rounding issues. So then to find the area of the green combines a different calculus concept, and that would be find the area between negative pi over 2 and pi over 2 of cosine, and then subtract out that maximized rectangle, right? Because if you're trying to find the minimum area of the green, you'd want to cut out the biggest rectangle of red. This was the free response question. So here we go. Question 1. Which of the following is an equation of the tangent line? Well, the equation of the tangent line, we need a point and a slope. Looks like I already have my point xy, so I need to find my slope by taking the derivative with respect to x. So this is going to be 2x minus, product rule is going to say first times the derivative of the second plus the second times the derivative of the first, and then the derivative of 10 is 0. So I can isolate dy dx right now, but I also know that I only want dy dx when x is 1 and y is negative 3. So I'm going to go ahead and do that. So 2 times 1 minus 3 times 1 dy dx is what I'm looking for. Plus, that was supposed to change colors, negative 3 times 3 equals 0. So 2 minus 3 dy dx, this negative sign is going to distribute. So this was negative 9, but now it's going to be positive 9. So I'm going to subtract this 11 to the other side. So I get negative 3 dy dx equals negative 11. So it looks like my dy dx is equal to 11 thirds. Oh, good. It's down there. I was like, wait a second, I don't see my answer. Dy dx equals 11 thirds. So putting that together in the equation of a tangent line, we'd have y minus and x minus. And our point that we had was the point 1 comma negative 3, and the slope we just found was 11 thirds. So we're looking at answer choice E. Okay, sides and diagonals of a rectangle are above are strictly increasing. At the instant when x is 4, so this would be later, right? At the instant. We got all this information. What is the value of k? All right, well, the first thing we need to do is we need to relate our variables. So I'm going to have x squared plus y squared equals z squared. And I'm going to now relate their rates by taking the derivative with respect to time. So I get 2x dx dt plus 2y dy dt equals 2, I hate using z's, dz dt. Okay, so getting better. We have 2's and everything, so those can actually just drop out, right? 2, 2, 2. We know that x is 4, and we know that dx dt is equal to dz dt. So I'm actually going to replace that with a dz dt, because my thing I'm solving for has something to do with dz dt. So this will be plus, my y was 3, dy dt equals, well, now that it's later, if this is 3 and this is 4, we know that z is 5. All right, and so we're trying to make a relationship between dy dt and dz dt. So let's get things set up. This is our goal, right? Is to get dy dt equal to something times dz dt. So I need to get dy dt by itself. So I'm going to subtract 4 to the other side. So I'm going to have 3 dy dt equals a single dz dt, which means that a dy dt is equal to 1/3 of dz dt. Okay, so the trick there is recognizing that we do need to replace this dx dt with dz dt because we're eventually isolating dy dt and should only have dz's left. All right, sand is deposited into a pile with a circular base. The volume of the pile is this, the circumference. So dc dt is increasing, so positive, at a rate of 5 pi feet per hour. Later, when c is equal to 8 pi, what is the rate of change of the volume? So if I look here, okay, v is equal to 1/3 r cubed. The problem is, though, everything I have is dealing with circumference and not with the radius. So I need to somehow make an exchange between the radius and the circumference. Well, hopefully from geometry, we know that the circumference is equal to 2 pi times the radius, which means that the radius is equal to c divided by 2 pi. So what I can do is I can sub that in here. C over 2 pi cubed. So now what I really have is 1 over 2 to the third is 8 times 3 is 24 pi cubed c cubed. Now I can take the derivative with respect to time and everything is dealing with circumference. So derivative with respect to time, I'm going to end up with dv dt, which is what I'm looking for. This is just a constant, so it's going to hang out. If it's a constant, Ms. Schwartz, you should probably keep it how it is. Constant times this c to the third with respect to time will be 3c squared dc dt. That was a d. Okay, plugging more stuff in. We know that dc dt was 5 pi, so 5 pi goes here. We know that c is 8 pi, so c squared is going to be 64 pi squared, right? Because I took 8 pi and squared it. Still have a 3, still have a 1 over a 24 pi cubed. Well, let's start canceling. So we've got pi squared and another pi, which will cancel with that. 3 over 24 is actually 1 over 8. And then we still have a 64. 64 divided by 8. Uh-oh. 64 divided by 8. Am I missing something? Oh, duh. Times 5. I was like, wait a second. Something's not right there. So 64 divided by 8 gets us 8 times 5 is 40. 40 should be our final answer. All right. Oh, technically units, because it was dv dt, would have ended up being cubic feet per hour. Right? So feet cubed per hour. All right. Volume of a cylindrical tin can with a top and a bottom is to be 16 cubic inches. So, sorry, 16 pi cubic inches. So this is representing a volume. So a volume of a cylinder is going to be pi r squared h. The minimum amount of tin is to be used. What must the height in inches be of the can? Well, a cylindrical can with a top and a bottom. So cylindrical can okay, and our top then is going to have a radius of r, and our height is here. Our volume, pi r squared h, is supposed to be equal to 16 pi. So this is going to be my helper equation because I'm trying to minimize the surface area. And the surface area is going to be 2 circles, the top and the bottom, plus 1 soup label. So the soup label, if you remember this from class, we did one like this, is going to be equal to 2 pi r times h. Okay, so we have 2 circles, a top and a bottom, and we have 1 soup label. So this is unpeeling that lateral area of the can. So if I go to take the derivative right now to find the max, or to find the value to create a minimum, I'm going to have a problem because I have 2 variables. So I want to use this helper equation to sub in for one of these. So I notice that 16 over r squared is equal to h, because the pi's would cancel out. So that means that my surface area is equal to 2 pi r squared plus 2 pi r times 16 over r squared. I'm going to clean that up even a little bit more. 2 pi r squared plus 32 pi and then r to the negative 1. So now when I go to take the derivative, I end up with 4 pi r minus 32 pi over r squared. I'm going to set that equal to 0. So I'm going to add this 32 pi over r squared equals 4 pi r. I can cross multiply. This is me showing all of the work. You could have used your calculator if you wanted to. This will end up being 8 equals r cubed, which means that r is equal to 2, which is great, except the question asked for what h is supposed to be. So I go back to my helper, and h will end up being 4. 16 divided by 2 squared. All right, last one. This is all about taking that derivative with respect to time. So we have this equation where k is a constant. So I'm immediately going to write this as k times n to the negative 1. Which of the following best describes the relationship between the rate of change with respect to time? So I need to take the derivative of this with respect to time. Well, this will be du dt equals, k is just a constant, so it chills out. This is going to be negative 1 n to the negative second times dn dt because of that chain rule. Okay, taking the derivative with respect to time. So cleaning all this up, du dt equals, that negative sign can just go there, so negative k, this is 1 over n squared dn dt, which is looking like answer choice D. Okay, so just don't let the difference variables freak you out. We're used to dealing with x's and y's and taking the derivative with respect to time. Same thing's going on here, we just have a u and an n. Okay, so remember to jump on and ask your teacher if you have any questions. We're around for Google Meets. I believe today's work in remote learning, if that's what's happening, is pretty light. So let us know if you need anything.